statement about the 6 times plus 2 rule and LB conduit bodies is not true. The National Electrical Code (NEC) requires a minimum of 6 times the trade size of the largest raceway entering a conduit body or pull box. This requirement applies only if the total cross-sectional area of all conductors within the conduit body or pull box exceeds 40% of the cross-sectional area of the conduit body or pull box. Let's break that down. If you have a 2-inch conduit, the minimum spacing between the conduits would be 6 times 2 inches, resulting in 12 inches. However, the NEC provides allowances for using conduit bodies with smaller spacing, particularly if those conduit bodies are listed for use with a specific number and size of conductors. LB conduit bodies are designed and listed for use with multiple raceways. These devices are manufactured to meet the NEC spacing requirements. Therefore, using 2-inch LB conduit bodies with 2-inch PVC conduits is an approved practice, even if the spacing is less than 12 inches. In the example you provided, a 200 amp service using 3 2/0 wires in a 2-inch LB conduit body with 2-inch PVC is approved according to the NEC. To more deeply understand this concept, let's discuss NEC section 314.28, which addresses pull and junction boxes, conduit bodies, and hand-hole enclosures. This section contains the rules for sizing these enclosures to ensure adequate space for conductors. Subsections A1, A2, and A3 provide specific requirements based on the application. For straight pulls, as described in 314.28 A1, the length of the box or conduit body must not be less than 8 times the trade size of the largest raceway. This requirement ensures sufficient space for the conductors to pass straight through the enclosure without undue stress. For angle or U-pulls and splices, detailed in 314.28 APWO, the distance requirements differ. Here, the distance between each raceway entry inside the box or conduit body and the opposite wall must not be less than 6 times the trade size of the largest raceway in a row. This is the origin of the 6 times rule. This rule applies to situations where conductors are bent at an angle within the enclosure. If there are multiple rows of raceways entering the enclosure, the minimum distance between raceway entries in each row must also adhere to this 6 times rule. Additionally, the distance between raceway entries and the enclosure's wall opposite those entries needs to be considered. 314.28 A3 covers conductor allowance. Where an enclosure contains conductors of size number 4 or larger, and where the total cross-sectional area of all conductors in the enclosure exceeds 40% of the cross-sectional area of the enclosure, the minimum dimensions specified in 314.28 A1 and 314.28 APWO must be increased. This is to prevent overcrowding and potential damage to the conductors. So, the 40% fill rule is a key factor in determining whether the 6 times rule applies. If the conductors don't exceed 40% fill, the 6 times rule might not be strictly enforced, especially if the conduit body is listed for specific applications. LB conduit bodies are specifically designed and tested to accommodate certain conductor sizes and fill percentages. Their listing by a recognized testing laboratory, such as Underwriters Laboratories, signifies that they meet specific safety and performance standards. This listing takes into account the physical constraints of the LB conduit body and verifies that it can safely house the specified conductors without exceeding temperature limits or compromising insulation. The code emphasizes the importance of using listed or labeled equipment. Section 110.3b states that listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. This means that when installing an LB conduit body, one should carefully follow the manufacturer's instructions and any markings on the product itself. The listing typically specifies the maximum number and size of conductors that can be installed in the conduit body. If the installation complies with these instructions, it is considered code compliant, even if the spacing between raceways is less than the 6 times rule would otherwise require. Let's consider a practical example. Suppose you have a 2-inch LB conduit body installed in a 200 amp service, as mentioned earlier. This LB conduit body contains 3 2/0 AWG conductors. To determine if the installation is compliant, you need to consider firstly the listing of the LB conduit body. Check the product's label or the manufacturer's specifications to determine the maximum number and size of conductors it is approved to accommodate. Secondly, calculate the cross-sectional area of the conductors. The cross-sectional area of a 2/0 AWG conductor is approximately 0.133 square inches. With 3 conductors, the total cross-sectional area is 3 times 0.133, or 0.399 square inches. Thirdly, determine the cross-sectional area of the LB conduit body. This information is usually available in the manufacturer's documentation. Let's assume the LB conduit body has a cross-sectional area of 2 square inches. Fourthly, calculate the percentage fill. Divide the total cross-sectional area of the conductor's 0.399 square inches by the cross-sectional area of the conduit body 2 square inches and multiply it by 100. This gives you 19.95%. Since the conductor fill is less than 40%, the 6 times rule does not strictly apply. As long as the LB conduit body is listed for use with 3 2/0 AWG conductors, the installation is compliant. It's important to note that the NEC is a comprehensive document and its interpretation can sometimes be complex. Local jurisdictions may have additional requirements or interpretations that differ from the national code. Therefore, it's always advisable to consult with a qualified electrical inspector or engineer to ensure full compliance with all applicable codes and regulations. In summary, when dealing with conduit bodies, particularly LB conduit bodies, remember firstly the 6 times rule applies when the conductor fill exceeds 40% of the conduit body's cross-sectional area. Secondly, listed LB conduit bodies are designed and tested for specific applications and conductor sizes. Thirdly, always follow the manufacturer's instructions and the product's listing when installing conduit bodies. Fourthly, consult with local authorities to confirm compliance with all applicable codes and regulations. Let's discuss some additional considerations for working with conduit bodies. It's important to select the appropriate type of conduit body for the specific application. Different types of conduit bodies are designed for different purposes, such as making bends, providing access to conductors for pulling or splicing, or transitioning between different types of raceways. LB conduit bodies, as we've discussed, are typically used to make 90-degree bends in conduit runs. LL and LR conduit bodies are similar to LB bodies, but the openings are on the left and right sides, respectively. T conduit bodies are used to create a T-junction in a conduit run. C conduit bodies are used for straight pulls, providing access to conductors without changing direction. When selecting a conduit body, consider the following factors. Firstly, the size and type of raceway being used. Ensure that the conduit body is compatible with the size and type of conduit or tubing being installed. Secondly, the number and size of conductors. Verify that the conduit body is listed for the number and size of conductors being installed. Thirdly, the environmental conditions. Choose a conduit body that is suitable for the environment in which it will be installed. For example, in damp or corrosive environments, use a conduit body made of corrosion-resistant materials, such as PVC or stainless steel. Fourthly, the accessibility requirements. Select a conduit body that provides adequate access to conductors for pulling, splicing, and maintenance. In addition to selecting the right conduit body, proper installation is crucial for ensuring a safe and reliable electrical system. Follow these guidelines when installing conduit bodies. Firstly, prepare the conduit ends properly. Deburr and ream the ends of the conduit to remove any sharp edges or burrs that could damage conductors. Secondly, apply conduit lubricant. Use a listed conduit lubricant to reduce friction and make it easier to pull conductors through the conduit body. Thirdly, tighten connections securely. Ensure that all connections between the conduit body and the raceways are tight and secure. Use appropriate tools, such as a pipe wrench or channel lock pliers, to tighten fittings. Fourthly, support the conduit body properly. Support the conduit body independently of the raceways to prevent stress on the connections. Use conduit straps or hangers to support the conduit body. Fifthly, protect the conduit body from damage. Protect the conduit body from physical damage by installing it in a location where it is not likely to be struck or crushed. If necessary, use a guard or enclosure to protect the conduit body. Furthermore, consider the impact of temperature on conductor ampacity. The NEC contains tables that provide ampacity ratings for conductors based on their size and insulation type. These ampacity ratings are based on an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be derated to prevent overheating. The NEC provides correction factors for adjusting ampacity based on temperature. These correction factors are found in Table 310.15b. For example, if the ambient temperature is 40 degrees Celsius and the conductor has a temperature rating of 75 degrees Celsius, the correction factor is 0.88. This means that the ampacity of the conductor must be reduced by 12%. When conductors are installed in conduit, the heat generated by the conductors can raise the temperature inside the conduit. This is especially true when multiple conductors are installed in the same conduit. The NEC requires that the number of conductors in a conduit be limited to prevent overheating. Table 310.15b3 provides adjustment factors for the ampacity of conductors based on the number of current-carrying conductors in a raceway or cable. For example, if there are 4 to 6 current-carrying conductors in a conduit, the ampacity of each conductor must be reduced by 20%. When calculating the ampacity of conductors in conduit, it's important to consider both the temperature correction factors and the number of conductor adjustment factors. The lowest ampacity value determined by these factors should be used. In addition to ampacity derating, it's also important to consider voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. To minimize voltage drop, use conductors that are large enough for the load being served. The NEC provides tables that can be used to calculate voltage drop based on conductor size, length, and current. Another important aspect of electrical installations is grounding and bonding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip over current protective devices, such as circuit breakers and fuses. Bonding ensures that all metal parts of the electrical system are electrically connected, which minimizes the risk of electric shock. The NEC contains detailed requirements for grounding and bonding in Article 250. These requirements cover the size and type of grounding and bonding conductors, as well as the methods for connecting them to the electrical system. Proper grounding and bonding are essential for ensuring the safety of people and property. In conclusion, understanding the NEC requirements for conduit body spacing, ampacity derating, voltage drop, and grounding and bonding is crucial for designing and installing safe and reliable electrical systems. Always consult the NEC and local codes to ensure compliance with all applicable regulations. When in doubt, seek the advice of a qualified electrical inspector or engineer. By adhering to these guidelines, you can help to prevent electrical hazards and ensure the proper functioning of electrical equipment.